Our essential question today: why would anyone create a system of equations, and how can they be useful? A system of equations definition is a set of two or more linear equations containing two or more variables. A system of linear equations definition, you want to be writing this definition down, is a set of two or more linear equations containing two or more variables. Then a solution to a system of linear equations is going to be the two variables is an ordered pair that satisfies each equation in a system. If so, then the ordered pair is considered a solution. Okay? A system of equations is going to be written out, when you see it, with two equations, one on top of the other, with a bracket next to it. That's considered a system of equations. Okay? The solution is any ordered pair that solves both equations. Okay? In other words, it's an ordered pair in which both lines cross. Right? The solution to a system is the point where the lines cross, the point in the middle. Okay? It's the only point of these two lines that appears on both lines. So a solution to a system of equations is a point that appears on both lines. Easy enough is where they cross. So today we're going to be solving them by graphing. Okay? Meaning we're actually going to draw the graph and we're going to look and see where do they cross. Okay? Now you can do this by making a table, plotting the points, and graphing each line. But you really want to have your system in y equals mx plus b form to make it easier to graph. It's a whole lot faster. Alright, so the first question is, we just want to know, is this ordered pair a solution or not, before we even try and graph them. So this case, this would be where, let me get out my note paper rather than my graph paper here. There we go. This would be where you're given 4, 1, maybe as an ordered pair. It could be any ordered pair it gives you. And then you're given this system of x plus 2y equals 6 and x minus y equals 3. Okay? And so you're asked, is this ordered pair a solution to this system of equations? So to figure that out, we're just going to plug in the variables, or the values. So I'm going to step 1, plug in x and y, and solve the first equation. Okay? Step 2, you're going to do the same thing with the second equation. So repeat with the second equation. So our first equation is x plus 2y equals 6. So I'm going to plug in my x and y values. So x is 4, y is 1, then I'm going to solve. I get 4 plus 2 equals 6. 6 does equal 6. So this is true. So since it's true on the first equation, now I have to test it with the second equation. If I found that it was false on the first equation, there is no need for me to solve the second one because I've already proven that it doesn't work. It doesn't work with the first one. Who cares if it works with the second one? It didn't work with the first one. So the next one, I've got x minus y equals 3. I'm going to plug in my values. So x is 4, y is 1. So 4 minus 1 is 3. 3 does indeed equal 3. So it's true. So since it's true for both, they both work, then this is a solution. So then my answer would be yes, 4, 1 is a solution. That's your answer in a complete sentence. If it's a fill in the blank, all you have to put is yes. Now let's talk about actually graphing these. So you're given a system of equations and you're asked to solve by graphing. The easiest and fastest way is to do it in your calculator. We're first going to do it by hand, but if you want to do it in your calculator, if you look in your calculator cheat sheet that I gave you several weeks ago, in November before we left for Thanksgiving, you'll find I've shown you exactly how to enter this in the calculator. We'll also have some time in a couple weeks to practice using the calculator to do this. So by hand, if I'm given the system of equations y equals x minus 3 and y equals negative x minus 1, then I can plug these in and graph them. Since they're both already in y equals mx plus b form, I'm going to get a little closer here. There we go. Since they're both already in y equals mx plus b form, all I have to do is graph. My b is there, that's my y-intercept, and on both of them my slope is 1 or negative 1 because there's no number in front of the x. So my first equation is negative 3, and I'm actually going to do these in two different colors so we can really see them. Let's start with green here. Negative 3. So I'm going to put my dot on the y-axis of negative 3, and then my slope is a positive 1, so I'm going to have an upward slope, and I'm going to go up 1, right 1. Remember, we always go right if we're going up or down, unless we're making the line backwards. There's my first line. So that's this one right here. That's the y equals x minus 3. And then my second one is going to be, we're going to do that in a different color so we can see it, negative x minus 1. So I'm going to put at negative 1. This one has a negative slope, so it's going to have a downward slope. And it's negative 1, so I'm going to go down 1, right 1, down 1, right 1. You can already see where they crossed. Get out my ID badge here. Using that as a straight edge, so I don't have to get a ruler. And there it is. I can see where the two lines cross. I see that my lines cross right here. That's the point where they cross. They cross at 1, negative 2. 1, negative 2. So this is my solution to the system. It would be 1, negative 2. Let's do another example. What if I've got x plus y equals 0 and y equals negative 1/2 x plus 1? Okay. Now in the last problem we didn't write out any steps because all we did was have to graph them. That was our only step, is graph and find the point where they cross. Well, in this one, they aren't set up in y equals form, so I'm actually going to have to do an extra step here. Let's write ourselves some steps. So to solve by graphing, okay, to solve by graphing, step 1, we're going to put all equations in slope-intercept form. Put all equations in slope-intercept form. Remember, that's y equals mx plus b, where b is your slope, your y-intercept, and m is your slope. So b is your beginning, m is your movement. Step 2, graph both lines. And then step 3, find the point where they cross. Okay. Now, what if you came across some other special lines? What if they don't cross? Okay. What if they don't cross? For example, if they are parallel lines, they're never going to cross. So then there would be no solution. If you have the same line, you have two different equations that make the same line, then there would be infinite solutions. Infinite solutions. You can tell I'm not a spelling teacher, because every point is where they cross because they're the same line. Okay, so there's our steps. Let's go back to our graph and let's graph these. So my first step is I've got to turn this first equation into a y equals form. Okay? Y equals would need to have y by itself, so I'm going to subtract the x from both sides. When I do that, I end up with y equals negative x plus 0. My other one's already in y equals form, so I'm going to do y equals negative 1/2 x plus 1. There we go. Now they're both in y equals form, so I can graph them. The first one has 0 as the y-intercept, so that's where I'm going to put my first dot. Then I have a negative x, so that means I have a 1, an imaginary 1 right there in front of the x. So my slope is negative 1. So it's going to go down 1 over 1. It's going to have a downward slope. And there it is. Let me turn that into a straight line. Okay, there's my first line. Then my second line crosses at positive 1 and then has a slope of negative 1/2. So that means it's going to go down 1 and over 2, but it's still going to have a downward slope. It's going to go down 1 over 2. Down 1 over 2. Down 1 over 2. Okay, and then I'm going to go up 1, left 2. So now I'm going the opposite direction. Okay. Draw my lines. Now you can see with these two lines, it's really important to make sure your lines go all the way to the edge of your graph and not stop them in the middle like I did on this pink line, because if I stopped it, I wouldn't see exactly where they cross. Up 1 over 1. Up 1 over 1. Up 1 over 1. In fact, I even got my line a little bit crooked there. Okay, that's the key to using a ruler. If you're not using a ruler or some sort of straight edge, you can easily get your line messed up, like I did there. Okay, you want to make sure you're using a ruler. So the point where they cross then is right here. That's their cross point, which is going to be negative 2, positive 2. So that's the solution to this system of equations. Okay. Now, why would somebody do this? In real life, this comes in real handy when you're trying to compare maybe cell phone plans or cable plans or wireless internet plans to figure out which plan might be equal or which one would be greater or less. This is also really good to use when you're trying to figure out profit and loss. If you know you sell this much product and you made this much money and you know it cost you this, you want to figure out where's your break-even point. So you're comparing cost to money earned. So if you were, say maybe you had a lawn business or you're selling lemonade at a lemonade stand or maybe a bake sale and you know you spent this much money and you want to compare it to how much money you made to know where you break even, meaning how much money to make $0. Break-even point is where it cost you nothing, but you didn't make any money either. Those would be good examples of when you might use a system of equations.